Okay, so hi there. We're going to continue with our videos in conditional probability. And in this video, we're going to have this example number 3, and I guess example number 4 and 5. We'll see what we can reach here. Now, suppose that we have a sample space S. It is the population of adults in a small town who have completed the requirements for a college degree. The following contingency table shows the distribution of the adults according to gender and employment status. So we have males and we have females, employed and unemployed. And one of these individuals is selected at random to represent the townsfolk in a town council meeting. We denote the following events to be M, that he's a man, and E, that he is employed. So we want to get the probability that he is a man given that he is employed. So firstly, I think it's much better that we will be adding things up. Like for example, in the male here, if we're going to add them, it's going to become 500. And for the female, if we're going to add them, it's going to become 400. So overall, we have 900 people here. For the employed, if we're going to sum them up, it's going to become 600. And for the employed, it's going to be 300. If we're going to see the grand total, it's going to be 900. So we are interested in determining the probability of getting a male given that he is employed. So we can actually refocus ourselves in the employed one because it's the one which is the given or the one that occurred already, the event that occurred already. And we're going to get the intersection of male and employed, which is 460. So our answer will be 460 divided by or over 900. We can just simplify that. It may become 46 over 90. Can we simplify that further? Maybe divide them both by 2. 23 divided by 45. So I think that's it because 23 is a prime number. So that will be, for example, number 3. I hope you learned something there. Let's now move forward to the next example. So we have example 4. We're now asking the probability that regularly scheduled flight departs on time is, we call that D, probability of D, it's 83%. The probability that it arrives on time, probability of A, 92%. And the probability that this certain plane or a certain plane departs and arrives on time, and that's the probability of their intersection, which is 78%. We are asked to find the probability that a plane, letter A, arrives on time given that it departs on time, or given that it departed on time. And for the B, it departed on time given that it arrived on time. So we can simply or get the value or the meaning of this first. For the letter A, arrives on time given it departs on time. So the given is depart. So we want to find the probability that it arrives on time given that it departs on time. So a probability of A given D. For letter B, what's the probability that it departed on time given that it arrived on time? So probability of D given A. So how do we get number 1? Find the intersection, which is 0.78. We divide that by the probability of D alone. That's 0.83. And that's our answer right there. Just do the necessary simplifications if it can be simplified, that the calculator decide, or let the calculator do the work. You can make this like, 78 over 83. Not sure if 83 is a prime. Anyhow, for the number 2, the intersection is 0.78 divided by 0.92. So I'm pretty sure they're both divisible by 2. So this becomes what? What's 78 divided by 2? 39 divided by 92 divided by 2. It's gonna give you what? 46, if I'm not mistaken. Okay, so that's going to be the final answer if it cannot be simplified even further. And This will be our example 5, the last example, I suppose. The following tables gives data on the type of car grouped by diesel consumption owned by 100 people. One person is chosen at random. Find the probability of choosing. So we have low, medium, high rated car, and we have a male, female drivers. So I think for number one, what's the probability that uh, of choosing a female given that she has a low rated car? So the probability of, let's call F as female given that she has a low rated car. Probability of F given L. For number two, a person who has a high rated car given that he is a male. So probability of, let's call it H, high rated car given that he's a male. And for the third one, the probability that a person who has a medium rated car given that she is a female, probability of medium, I'll call it MED, that we won't be confused with male, given that she's a female. So for number one, we can just focus on the given, which has a low rated car. So probability that she's a female, get the intersection, it's going to become 23 over 35 for number one. 23 is a prime, so that's the final answer. For number two, we will focus ourselves in a given that he is a male, so we're gonna focus on this here. Probability that he has a high rated car, so it's gonna be 7 over 52. 7 is a prime, so okay. And lastly, for number three, yeah. A person who has a medium rated car, given that she's a female, we're gonna focus on the female and get the medium rated car. That's gonna give us 21 over 48. So 21 over 48. Can that be simplified? Yeah, they're both divisible by 3. We can make it 7 over, what's this, by 3? 1, 6. Okay, and that's it. Those are our answers for this example 5. And I guess those are all the examples for conditional probability. In the next part, we will be talking about multiplicative rules. So we'll be seeing each other in the next video. Right over this will be the multiplicative rules. So thank you very much for watching and see you. Goodbye.